Hello dear students. So in this video we will be doing one derivation, and the topic of the derivation is to find electric field at a point along axial line of a dipole. So we know that a dipole is a system which has two equal and opposite charges separated by a small distance. So as you can see in this diagram, so we have this dipole AB. So this AB is an electric dipole which has charge minus q at A plus q at B, and they are separated by a dipole length of twice A. Dipole length is the distance between the two charges. So twice A here is the dipole length. Now from the center O of the dipole, the distance up to point A and to point B will be same, that is A and A. Adding these two, we get twice of A. Now our main theme is to find out electric field at any point, let's say P, which is along the axial line of the dipole, along the axis of the dipole. The line which passes through both the charges is the axis. So along this axial line at any point P, we are supposed to find out the expression for electric field. So let's say that this point P is at a distance of r from the center of the dipole. So from the center up to this point, the distance is r. And from point A up to point B, the distance is r plus A. And from point B to point P, the distance is r minus A. So if you are not able to grab it, then we can just find this value. So AP, from the diagram, we can write it as AO plus OP. So this distance AP, we can write it as AO plus OP. So AO is nothing but it is A, and OP is your R. So the value of AP becomes R plus A or A plus R. Similarly, the distance BP, we can write it as OP minus OB. So OP is your R minus OB is your A. So that's why we have this distance AP as R plus A and this distance BP as R minus A. I hope this is clear now. So let's go to the derivation. So we will find out the electric field at point P separately due to minus q charge at A and plus q charge at B, and then we will find the total. So in order to find out the electric field at P due to minus q and plus q charge, we need one expression which is E is equals to 1 by 4 pi epsilon naught q divided by R square. So we will be using this expression to find out electric field at P separately due to minus q charge at A and then plus q charge at B. So let's start. So the electric field at point P due to minus q charge at A can be written as EA equals to 1 by 4 pi epsilon naught q divided by AP square, because the distance between P and A is AP. So AP square, and since electric field is a vector quantity, it has direction. So for negative charge, the direction of electric field line is always towards. So since we have a minus q charge at point A, so the electric field at P due to this charge will be directed towards the charge. Since we have a negative charge at A, so the electric field will be directed towards the charge. So this is the direction of electric field EA. Right? Now let's expand this. Okay, so that let's write down the direction along PA. So towards PA will be the direction of the electric field EA. Now let's simplify this equation further. So we have EA is equals to 1 by 4 pi epsilon naught q divided by the value of AP, as I've already mentioned, AP is R plus A. So we can write this as R plus A whole square. So let this be our equation number 1. Right? So similarly, we can now find out the electric field at point P due to plus q charge at B. So since for point A we have written electric field as EA, for point B let's write it as EB. So the electric field at point P due to plus q charge at B will be EB is equals to 1 by 4 pi epsilon naught q divided by the distance is BP, so BP square, and the direction of the electric field. Now as you can see, we have a positive charge at B and for positive charge, electric field is away from the charge. So the direction of EB will be this side. I hope this is clear. For negative charge, the electric field is towards. For a positive charge, electric field is always away from the charge. So the direction of EB will be along BP. So let's simplify this equation further. Let's put the value of BP. So EB is equals to 1 by 4 pi epsilon naught Q divided by, the value of BP is R minus A. So we'll write R minus A whole square. Let this be equation number 2. So we have separately found out the electric field at P due to minus Q charge at A and then due to plus Q charge at B. So we got two equations, EA 1 by 4 pi epsilon naught Q divided by R plus A, this will be whole square, and EB equals to 1 by 4 pi epsilon naught Q divided by R minus A whole square, and the direction of EA is along PA towards the charge, and the direction of EB is along BP, that is away from the charge. So now what we will do here is we can find out the total electric field at P due to the dipole as a whole. So we will calculate the total electric field at this point P. Now if you look at the value of EA and EB, if you look at the direction of EA and EB, first of all, EA is along PA and EB is along BP. That means they are in the opposite direction. Now, in order to find the total field at P, so we have to know which value is greater here. Now, if you look at the expression for the electric field, it was E equals to 1 by 4 pi epsilon naught Q divided by R square. So if you remove this constant and equals to sign, we can write this as E proportional to 1 by R square, which means electric field is inversely proportional to the distance. So if the value of distance is less, then it means that the value of electric field is more. Now between the two electric fields, EA and EB, which one is greater? In order to find out that, we will see the distance of point P from the respective charges. So as you can see, P is at a distance of R plus A from the minus Q charge, and point P is at a distance of R minus A from plus Q charge. So obviously R minus A is a smaller value than R plus A, which means that the value EB will be greater than EA. So in order to find the net electric field at the point P, we will take this into consideration. So since they are in the opposite direction, we can calculate the net electric field by subtracting greater value and smaller value. So the total electric field at point P will be EB minus EA. Here you can write, since the value of EB is greater than EA. Now we can replace the value of EB and EA from equation 1 and 2. So we have E is equals to the value of EB 1 by 4 pi epsilon naught Q divided by R minus A whole square minus of 1 by 4 pi epsilon naught Q divided by R plus A whole square. So this we have obtained using equation 1 and 2. So we will now simplify this equation. And also you have to mention the direction of this net electric field. So the direction of this net electric field will be along the same direction, the value of which is greater. So here obviously the value EB is greater than EA. So the direction of the net electric field will be also along BP, right? So let's now simplify this equation further. So E is equals to, you can take out the common outside. So we have 1 by 4 pi epsilon naught common. Q in the numerator is also common. So inside the bracket we will have 1 divided by this term, that is R minus A square whole square, minus, then we have this term, that is 1 by R plus A So we have to keep on simplifying this equation further. So how can we do that? So 1 by 4 pi epsilon naught q. Now here we can take the LCM of these two terms. So the LCM of r minus a whole square and r plus a whole square will be r minus a whole square times r plus a whole square. So here we already have r minus a whole square. So 1 has to be multiplied with r plus a whole square. So here we have r plus a whole square. This minus sign is here. And then here we already have r plus a whole square. So we need to multiply with r minus a whole square. So let's further simplify this equation now. So we can keep this term as it is. There will be no change. So here we will now use one formula. This is in the form of a plus b into a minus b. So a plus b into a minus b can be written as a square minus b square. So we can write this as r square minus a square, and we have whole square in both the terms, so we'll have whole square here. So here we have used in the denominator the formula a plus b into a minus b is equals to a square minus b square. If you compare it with this one, then we have r plus a, r minus a can be written as r square minus a square. That's what we have written here, and this has whole square in both the terms, so this whole square. I hope this is clear. Now let's see in the numerator. In the numerator we have, we can use it a square minus b square also, or we can use a plus b whole square and a minus b whole square. It's up to you. So let's use the formula a plus b whole square and a minus b whole square. So for this first term, we will use the formula a plus b whole square. So a plus b whole square is nothing but a square plus b square plus 2ab. Then this minus sign is there. Be careful with the minus sign. Wherever we have a minus sign, the sign will change, so we need a bracket here. So this is in the form of a minus b whole square. So this will be a square plus b square minus 2ab. So we have used three formulas here, a formula here. One is a plus b into a plus b into a minus b is equals to a square minus b square in the denominator. And in the numerator we have used a plus b whole square as a square plus b square plus 2ab, and a minus b whole square as a square plus b square minus 2ab. So I hope up to this it's clear. Now let's further simplify this equation. Now let's first open this bracket with the minus sign. So if you open with the minus sign, there will be no change here. So it will remain as it is. Now this minus into plus, this becomes minus, so minus r square. Minus into plus becomes minus, so minus a square. And here we have minus into minus plus, so we will have plus 2ar. And in the denominator we are keeping it as r square minus a square whole square. Now in the numerator we can cancel some of the terms, so let's cancel that. So we can see that r square and r square is getting cancelled. Similarly a square and minus a square is getting cancelled. Further we have 1 by 4 pi epsilon naught q into, now twice ar plus twice ar will give us 4 times ar, and in the denominator we have r square minus a square whole square. Now in the next step what we will do is we will split this 4ar as twice a into twice r. Now why we need to do that is because, let me show you. So we can write this as twice a into twice r. Now we are doing this simply because we have the product of q and twice a. Q is the charge twice A is the dipole length, and we call this product as the dipole moment. So we can replace this Q into twice A with the dipole moment here. So we can write E is equals to 1 by 4 pi epsilon naught. This Q into twice A will be replaced by P, which is the dipole moment, twice R divided by R square minus A square whole square. So here we have replaced P, which is dipole moment, is equals to Q times twice A. So I hope this is clear. So this Q into twice A, we have replaced it with P. So this is one equation. Now further we can say that if the value of R is much greater than A, alright, R is the distance of the point P from the center. So if R is much greater than A, then the value R square minus A square becomes nearly equal to R square. So let this be equation number 3. So we will put this value here. So putting equation, okay, that's right, putting in equation 3 we have, so let's put it here. So it becomes E equals to 1 by 4 pi epsilon naught P into twice R divided by, this can be simply written as R square only, so R square whole square. Alright, so now in the denominator, R square whole square can be further written as E is equals to 1 by 4 pi epsilon naught P into twice R divided by R to the power 4. So let's cancel one R in the numerator, one R in the denominator. So our equation becomes E is equals to 1 by 4 pi epsilon naught twice of P divided by R cube. And this is the required equation for electric field along the axial line of an electric dipole. So in this equation, P is your dipole moment, E is your electric field at the point P. Alright. So this derivation is important. So you can go through the derivation. If you want the notes and all, you can just comment in the comment section, and do like, share and subscribe my channel. This is the first video that I am uploading for class 12th. So give me some feedback so that I can improve and you can get benefit of that. Thank you everyone.